Hello. In this video we are going to talk about the anatomy of a 3D model. What is it that creates a 3D model and what is a 3D model? Well, there are three main components that a 3D model is made of. The first one being a vertex. Vertex is nothing but a point in space. A 3D model is actually just a collection of vertices, which is the plural of vertex, connected to each other through edges. If we add another vertex, it gets connected, and that connection is something we call an edge. The edge is the second component that a 3D model is made of. If we would add a third vertex, we would get two more edges, and we finally get something that we call a polygon. A polygon is the main building block of every 3D model. This type of polygon is called a triangle. As you can see, this word here, trees, that's actually the short for triangles. And you will see a lot of game engines and 3D modeling software referring to these polygons as trees, because no matter how many vertices a polygon has, in this case 4, or in this case 6, they're called n-gons, and these are called quads. So we have a tri, a quad, and n-gon. N-gon being each polygon that has n number of vertices. So basically any polygon above 4, but some people refer to quads as n-gons as well. Technically all three types are n-gons because n can be any number. But in truth, all n-gons or quads are just a collection of triangles. We don't see them because 3D software doesn't show us triangles unless we want it to, because it is a lot more convenient to do 3D modeling in a quad-based 3D model due to a lot of reasons, one of them being predictable edge loops, for example. Let's say, for example, we have a shape like this. We can now create predictable loops, which is very convenient. But what's basically going on is this model gets rendered by the machine like this. And if we modeled with a model like this, we could not create loops because the software doesn't know where the edge loop should go. So for the sake of convenience, we are modeling in quads. N-gons have a lot of their own problems, and we're not going to be covering that for now, but it's good that you just know that they exist. Now that we know that a 3D model is just a collection of points in space connected to each other by edges and forming faces or polygons, we now understand what a 3D model is made of. Now, these vertices have their own 3D representation in space, as you can see, but they have another one, something we call a UV space. Now, what is a UV space? UV space is a two-dimensional projection of a 3D model. This shape here is the unwrapped, as we call it, model in the UV space. U being the horizontal and V being the vertical axis. Why do we call it U and V? As far as I know, simply to not call it X or Y, simply to not confuse it with our coordinates, with our axes in in our 3D space. So U and V, you can observe it as a X and Y, but in a two-dimensional space. Now, each of these vertices has their own X, Y, and Z value in a 3D space, but it has its own U and V value in the UV space. As you can see, as I hover over this vertex, it gets highlighted in the UV space. Why do we have this 2D unwrapped version of our 3D model? Because of texturing. This space here is used for textures. Textures are usually created in a square manner. So you would place a square texture in this space here. So when you assign a texture to a model, it gets placed in this 2D space. Let's put this, usually called a checker texture. As you can see, if we select this face, we can see that these two zeros are placed on it. And in the 3D view, we can see the same thing happening. If we were to move the face in the UV space, you would see the texture moves as well, because the vertices and therefore edges and therefore faces get their different space in the UV space and thus display different parts of the texture. Now, as you can see, if we move the UV, it doesn't affect the XYZ positions of our components in the 3D space. And vice versa, if we move our vertices in the 3D space, nothing happens to the 2D version of our 3D model. This is the automatically unwrapped example because all polygon primitives in Maya get their own default unwrap. But we as 3D artists can manipulate the UV space any way we want. We can split these and create shells. We can sew them together. We can scale them. Rotate them. Basically anything you can do in a 3D space. These were the main things you need to know about a 3D model before you start creating stuff. There are various other properties of each of these components that we are not going to get into in this video, but we are going to cover them in the following videos. So thank you for watching, and make sure to watch the next one, as we are going to go a bit more in depth about the properties of vertices.